Our planet is constantly changing. Have you ever wondered how towering mountains became gentle hills, or how massive canyons and underground caves are formed? These changes are driven by exogenic processes. These are natural forces that reshape the Earth's surface over time.
Exogenic processes are external forces fueled by gravity, water, wind, and ice. These processes break down, transport, and deposit materials, giving rise to the landscapes we see today. Among these various ways, we'll delve into how stream and groundwater erosion play significant roles.
Stream erosion happens when flowing water like rivers and streams cuts through soil and rock, creating valleys, riverbanks, and iconic landmarks like the Grand Canyon. Over time, this movement of water shapes the surface through processes like abrasion, hydraulic action, and sediment deposition.
Groundwater erosion, on the other hand, occurs beneath the surface. Water seeps into the ground, dissolving rock, especially limestone, and forming underground caves, sinkholes, and other karst landscapes.
Tray.
To demonstrate these processes, we'll use 500 ml of water, sand, loam soil, and rocky soil with pebbles, a marker, an aluminum tray with holes, a protractor, a ruler, and gloves.
Using a ruler, measure the thickness of each sample. Make sure that each soil reaches an equal flat height of 1 inch and aligns with each hole.
We'll test an 80-degree slope. This represents a very steep gradient similar to mountain streams or waterfalls. At this angular slope, the water's velocity is at its maximum. It rapidly removes soil and carries larger sediments downhill. The erosion here is more destructive, resembling the processes that shape steep gorges or ravines in real life. The impact of water on different soil types, rocky, sandy, and loam, varies significantly due to their distinct characteristics. Rocky soil consists of larger particles and fragments of rock, which can provide stability on slopes. However, water can flow between these rocks, eroding smaller particles and leading to sediment displacement. The presence of rocks can limit the amount of soil available for erosion, but may also create channels for water flow that enhance erosion in specific areas. Sandy soil, characterized by its coarse texture and large particle size, drains quickly, which means it dries out rapidly after rainfall. While this allows for easy movement of water, it also results in low nutrient retention. As a consequence, during heavy rains, sandy soil is highly susceptible to erosion as water washes away loose particles without retaining moisture or nutrients effectively. Loam soil, a balanced mixture of sand, silt, and clay, retains moisture well while providing excellent drainage and nutrient holding capacity. When saturated with water, loam can resist erosion better than sandy soil due to its cohesive structure. However, if water flow is excessive, even loam can experience erosion as it loses topsoil. In summary, the differences in these soil types significantly influence the response to water flow. Rocky soil provides stability but can still erode. Sandy soil is vulnerable to rapid erosion due to its loose structure, while loam offers a balanced approach but can still be affected by heavy rainfall.
Experiment revealed how stream and groundwater erosion shape the Earth's surface. By exploring how water interacts with sand, loam soil, and rocky soil at different slopes, we've seen firsthand the force that sculpt valleys, caves, and landscapes over time. This process isn't just theoretical, it's happening all around us. For example, the Grand Canyon in Arizona was carved over millions of years by the Colorado River, showing the immense power of stream erosion. Meanwhile, karst regions like the Chocolate Hills and the limestone caves of Vietnam showcase groundwater erosion at work. At gentle slopes like 40 degrees, erosion is minimal, forming wide valleys. In steeper areas like the Himalayan foothills, where slopes resemble our 80-degree angle, Rivers erode rapidly, creating dramatic gorges and ravines. These are real-world examples of how slope and soil types determine the landscape. Now, what can we do if this is happening all around us? Basically, we made it worse. Human activities have accelerated these natural processes. Deforestation, mining, and poor agricultural practices increase soil erosion, especially in regions like Southeast Asia, where heavy rainfall already makes the land vulnerable. In urban areas, poor drainage system can accelerate groundwater erosion, causing sinkholes and structural damage. The best example is the city of Jakarta in Indonesia. Building wells, abusing seawater, and land expansion has caused more chances of sinkholes and structural damage to happen. But we also have the tools to mitigate these impacts. Techniques like reforestation, terracing on farmlands, and sustainable land management can slow down soil erosion. Meanwhile, in cities, engineering solutions can have permeable pavements and way better water management systems that prevent groundwater erosion and flooding. Finally, our experiment highlighted how understanding these processes can guide better decisions. Natural forces like water and gravity may seem unstoppable, but with these strategies, we can work with nature to protect our landscapes and communities. Thank you for joining us today, and see you soon.